Hello and welcome to another video by Johnny. Okay, so in this video, probably this is episode number 8, I think, or maybe 7. Yeah, I think 8. Okay, in this new episode, I will talk about types of bondings again, but now this video concerns about intermolecular forces. So in episode 7, it was about intramolecular forces, which is basically the forces inside the same molecule. Inside of the same molecule, you have many forces, like for example, polar covalent, non-polar covalent, or ionic bonds, okay? But that is intramolecular forces. Now we talk about the forces between the different molecules. See the difference? Between the different molecules with S. So there may be more than 2 or 3 or 4 different molecules or something like that. So intermolecular forces is in this video. So let's have a look at what I have prepared on the board here. So you can see that there are a few, just like 3 main intermolecular forces that everyone will have to learn, at least in their chemistry study. The first thing is the London Dispersion Force. London Dispersion Force, which is a weak force formed between molecule that has long structures. So basically, do you remember what we sometimes when you learn about physics, you heard about Newton's law of attraction, right? Newton's law of attraction say that if you have a bigger planet, it has a stronger force towards a smaller planet, for example. If you have 2 objects in space, their attraction will be proportional to their mass, which is how big you are, how heavy you are, the more the attraction to another stuff around you. So that is Newton attraction. What is it called? Newton law of attraction. But that concerns about a macro world, which is like massive planets and such. But now when we talk about micro world, which is about like small atoms, molecules, something like that, something similar applies. So if a molecule is long, it should have more interaction, more London dispersion force. So the longer the molecules are, the stronger the London dispersion force. It's like you're bigger, your mass is bigger as well, and you have more attraction force toward another molecule, which is quite understandable, right? However, if the molecule is compact, so if it's not like long chain, if it's like compact, like this, then the strength of the London dispersion force will decrease. Because it's easy, because you can see that London dispersion force requires the surface area in contact. Let's say this is a molecule and this is another molecule, and you have like connection between the two, like a lot of surface area. But now it's compact. You just have very little surface area in contact with each other. So that's why if you have less surface area in contact with each other between the molecules, the lesser the London force. Okay, in these 2 examples. Now, the second intermolecular force I would like to present today is the Dipole-Dipole Force, which is not so weak of a force. Let's look at this example. You can see that this is a chloroethane, and this is another chloroethane molecule. So if you have seen my episode number 7 video, I present to you the electronegativity of the atoms, the most common ones. So you would see that chlorine is 3.2, carbon is 2.5, and hydrogen is just 2.2 each of them. So you can see that this molecule, this region, it's more positive compared to this region, which is more electron dense, because it sucks away electron from this region. So this region is more partially negative. So this molecule of chloroethane is basically polar. Very well. Those are polar molecules. This one is also another polar molecules of chloroethane. So you see two polar molecules. They will come together, of course, because like attracts like. Okay. So now you can see that basically a positive and a negative, partially positive, will be attracted to each other, and vice versa. So basically, polar molecules will attract another polar molecules, and this is called Dipole-Dipole Force. And because it concerns about electronic attraction, so this is not very weak. It's actually quite relatively strong force, to be honest. And Dipole-Dipole Force arises when you have polar molecules in contact with each other. Because why? They form positive poles and negative poles. Negative pole and positive pole. That's what I call dipole, you know, di means two. So positive, negative, and negative, positive, so they find each other. Alright. So we also have another force, this is another concept. It's called van der Waals forces. But basically, van der Waals forces is just a combination of London and dipole-dipole. Nothing new. It's just how they classify it. Alright? Now, if there's no question, let's move on to one of the strongest intermolecular forces, which is the hydrogen bond. Hydrogen bonding or hydrogen bonds. So basically there are three cases of hydrogen bondings. But first, let me explain what is that and how does it form, okay? So if you have a lone pair of a highly electronegative atom, like for example, an oxygen 3.5. It has a lone pair, right? Okay, so this region will be negative, partially negative. And this lone pair will attract the hydrogen that is attached to another highly electronegative atoms. Need me to say again? Okay, so basically hydrogen bondings are formed between the lone pair of a highly electronegative atoms and the hydrogen that is attached to another highly electronegative atoms. Confusing, isn't it? Anyway, let's look at this example. You will see. For ammonia, NH3, there's a lone pair here. Wait, let's look at this one. Ammonia has a lone pair there. However, this ammonia, this lone pair, cannot form the hydrogen bonding with this hydrogen. How come? Why? Because this one is 2.5, this is 2.2, which is, it's not polar enough. So this one is not like partially positive enough. It's not positive enough. It's not attractive enough to form the bonding with this lone pair, okay? Therefore, the lone pair of this nitrogen cannot form the hydrogen bonding with this methane molecule, which is nonpolar. Right. But let's come back to this example about water. There are three water molecules here. So, of course, they are polar. And only polar molecules can form hydrogen bonds for obvious reason, because if you're not polar, then your hydrogen will not be partially positive, which means that you will not attract that lone pair of the oxygen or highly electronegative atoms. So this hydrogen is partially positive because it donates electron into this oxygen in the water molecules. And because it donates electron, it becomes partially positive. Because of that, it attracts the lone pair of this oxygen. Okay, understand now? Right. So it can form. They can in the same environment. Like for example, if you have a cup of water, the water molecules will connect to each other very much. So they interconnect, and it's a quite strong bonds, to be honest. It's what keep water together, like this. It keeps water molecules together. Otherwise, the water would just fly away, you know, disconnected. All right, so I did mention there are 3 cases of hydrogen bondings. The first case is the lone pair of the oxygen. The second case is the lone pair of the nitrogen. And the third case is the lone pair of the fluorine. Be careful. There are only 3 main cases of hydrogen bondings. The first thing is the lone pair of the oxygen, the lone pair of nitrogen, and the lone pair of the fluorine. Well, that's according to the textbook. I mean, that's also based on experimental result, so that's how it comes out. Okay. Right, so further explanation, let me look at this molecule. This is the fluoromethane. And the lone pair of this fluorine is very, very, very negative. Because why? Fluorine is 4.0. This is 2.5. So it basically sucks away all the electron from this region into itself. So this was very, very negative. And also the water, you know it. Negative here, positive there, positive there. So obviously a negative lone pair here will attract the hydrogens, which is partially positive. Okay. Ammonia. This lone pair attracts the hydrogen here, which is partially positive. Remember, if this hydrogen is not partially positive because of any reason, because it had donated electrons somewhere, if it's not partially positive enough, if it's not positive enough, it will not attract the lone pair of these highly electronegative atoms. Okay, I hope my explanation was not too long, it's not too confusing. If you find it confusing, please go back to the beginning when I talk about hydrogen bonding. And I hope the video was helpful for you. And beside these 3 main intermolecular forces, when we go into biochemistry, you will see other forces, like for example, disulfide bridges in protein, for example, electronic attraction and other things. But that's for later. For now, thank you so much for watching. Please like, subscribe, and share my videos. Also, please don't forget to click on the bell button to get notified by my new uploads, okay? Thank you so much, and see you. Bye-bye.